Here is the most annoying question in physics. Why can I cut a piece of cheese in half, and then half again, and keep going, but eventually I have to stop? Why is there a bottom to reality? We are told that the universe is made of particles, little distinct balls of stuff, Legos. And because they are Legos, reality is chunky, it's pixelated. We call this quantum. But I want you to forget everything you've been told about particles, because it's wrong. Actually, it's worse than wrong. It's a bad drawing of a beautiful truth. Here is the part nobody tells you. Nature didn't decide to make particles. Nature fell in love with waves. But when you trap a wave in a box, when you give it boundaries, it has no choice but to snap into specific shapes. It creates lumps. Quantum mechanics isn't about tiny particles. It's about what happens when you put infinity in a cage. Discreteness is not a property of the stuff. It's a property of the space it lives in. That sounds impossible. But by the end of this video, you won't just understand quantum mechanics. You'll understand why atoms, chemistry, and you, strictly speaking, are just music. Let me show you the trick. Walk to your kitchen. Turn on the tap. Look at the water flowing out. What do you see? You see a smooth, clear, continuous stream. It looks like a long, flexible sheet of glass. If I asked you to pour half a cup, you could. If I asked for a quarter of a cup, easy. Your intuition tells you that you can divide that water infinitely. You could take a drop, cut it in half, cut that half in half, and keep going forever. This is how we experience the world. We think reality is analog. Think of a slide whistle. You blow into it and pull the slide. Whoop! The sound goes up smoothly. There are no gaps. You can hit every single frequency in between the notes. Now think of a piano. Ding, ding, ding. You can hit C, you can hit C sharp, but you cannot hit the note hidden in the crack between the keys. Here is where your intuition fails. You think the universe is a slide whistle. It's actually a piano. Do this right now. Look at the light coming from your screen. It looks like a steady flood of brightness, right? A continuous wave washing over your face. Wrong. It is raining. Your screen is firing individual bullets of light, photons, at your eyeballs. It feels smooth only because there are trillions of them hitting you every second. If you could dim that light down low enough, lower, eventually the stream would sputter. Click, click, click. You would see the individual packets, the pixels of reality. We call this quantum. It just means packet or lump. But this creates a massive problem, a problem that drove physicists insane 100 years ago. Why? Why does nature refuse to be smooth? Why, when you get to the bottom, does the universe suddenly turn into Legos? If space is smooth and time is smooth, why is stuff chunky? The answer isn't about the stuff. It's about the danger of smoothness. Because if the universe actually was smooth, you wouldn't be here to ask the question. Let's go back to the year 1900. Physics was perfect. We thought we knew everything. We had Newton for gravity, Maxwell for light. Everything was smooth waves and smooth particles. But there was one tiny, annoying problem: the oven. Specifically, a black body, an ideal object that glows when you heat it, like a toaster filament or the sun. According to the smooth physics of the time, as you heat up an object, it radiates energy. It creates waves. And if energy is continuous, if it's a slide whistle, there is absolutely nothing stopping that object from vibrating at higher and higher frequencies. Think about it. A box can fit a few big, long waves, but it can fit millions of tiny, short waves and trillions of ultra-tiny waves. If nature is smooth, that oven should be pumping out infinite amounts of high-frequency energy. Imagine this. You turn on your toaster to make a bagel. The coils turn red, then orange. But then, according to classical physics, they should instantly blast out ultraviolet rays, then X-rays, then gamma rays. You don't get toast, you get a nuclear explosion. Every time you strike a match, the universe should end in a blast of infinite radiation. We call this the ultraviolet catastrophe. It's the most dramatic name in physics for a reason, because the math worked, but the reality was broken. The math said infinity, reality said red glow. Something was stopping the slide whistle from sliding all the way up. Something was choking the energy. This is where your intuition fights you. You think, maybe the atoms just get tired? Maybe they run out of fuel? Wrong. That's not how thermal equilibrium works. The problem wasn't the energy source. The problem was the math of smoothness. Classical physics assumed you could put any amount of energy into a wave. You could pour a 0.00001% drop of energy, or a 0.00011% drop, just like pouring water. But nature has a rule book we hadn't read yet. Nature looked at the infinity catastrophe and said, stop. To fix the universe, we had to break the smoothness. We had to introduce the lump. But how do you turn a wave into a lump? You need a box. This is the most important concept in quantum mechanics. Forget everything else for a second. If you understand this next minute, you understand why atoms exist. Imagine you are holding a long, heavy rope. Your friend holds the other end. You can shake that rope any way you want, fast, slow, big waves, little waves. Because the rope is loose, it's continuous, it's analog. You can send any frequency down the line. But now, tie both ends of the rope to a brick wall, tight. The rope is trapped. It is confined. It has boundary conditions. Now try to shake it. If you shake it gently, nothing happens. It just wobbles messily. But if you shake it at exactly the right speed, suddenly, snap! The whole rope forms a perfect arc, one big hump. This is the fundamental frequency, the first harmonic. Shake it a little faster. Nothing, just chaos. Shake it even faster. Snap! Two humps appear, a perfect sine wave with a node in the middle, the second harmonic. Do it again. Snap! Three humps. Here is the magic. Because the ends are tied down, the rope cannot vibrate at just any frequency. It is forbidden. The wave must fit perfectly between the walls. It has to be an integer number of half wavelengths. One hump, two humps, three humps. You cannot have 1.5 humps. The math forbids it. The geometry forbids it. Discreteness, the lumpiness, has emerged. Not because the rope is made of particles, but because the wave is trapped. Constraint creates quantization. Say that out loud. Constraint creates quantization. This is exactly how a guitar works. When you pluck a guitar string, it doesn't just make a random noise. It vibrates at a specific frequency because it is tied down at the bridge and the nut. If the string wasn't tied down, it would just flap around silently. But because it is constrained, it sings a note, an A, a C sharp. Those notes are discrete. They are quantum. Think about this. A free wave can be anything. A trapped wave must be something specific. Now, look at an atom. What is an electron? We used to think it was a planet orbiting a sun, a little ball whizzing around. Wrong. An electron is a wave, and an atom is a box. The electron is trapped by the positive charge of the nucleus. It is pulled in. It cannot leave. It is confined to a tiny space. So what happens to a wave when you confine it? It snaps. It can only vibrate in specific patterns, specific shapes, specific energy levels. We call these orbitals, but they aren't paths. They are the notes of the electron string. The reason an atom doesn't collapse, the reason chemistry works, the reason you are solid, it's because the electron is a guitar string that has run out of notes to play. But before we could understand that, we had to invent the math. And the man who did it hated it. This is the most ironic story in science. The father of quantum mechanics, Max Planck, was a conservative. He hated chaos. He hated radical ideas. He believed that nature was smooth, beautiful, and continuous. But in 1900, he was staring at that black-body radiation problem, the ultraviolet catastrophe. The math was broken. The infinite energy explosion was still there. He tried everything. Nothing worked. Finally, out of sheer desperation, he did something crazy. He said, what if, just as a mathematical trick, energy isn't continuous? What if energy comes in little packets? Imagine you are trying to pay someone $10.53. In a continuous world, you can give them exactly $10.53 worth of gold dust. But Planck said, no. Imagine you can only pay in pennies. You can give 1,053 pennies, or 1,054, but you cannot give 1,053.5 pennies. He called these packets quanta. He wrote down a simple equation. E equals hf. Energy equals a constant times frequency. Suddenly, the math worked perfectly. The ultraviolet catastrophe vanished. The infinite explosion disappeared. The curve matched the real world exactly. It was a miracle. But here's the punchline. Planck didn't believe it. He thought it was just a trick, a mathematical convenience, like rounding numbers to make the calculation easier. He spent years trying to get rid of it. He thought, surely nature isn't actually grainy like this. He was wrong. Nature is grainy. Energy doesn't flow like water, it drops like sand. It comes in specific chunks. The size of the chunk depends on the frequency. High-frequency light has big chunks of energy. Low-frequency light has tiny chunks. This explains why you don't get infinite UV radiation from your toaster. Because to make high-frequency UV light, you need a huge chunk of energy. And your toaster just doesn't have enough heat to make that happen. The universe is saved by the high price of admission. Planck accidentally discovered the pixel size of reality. He found the smallest possible action in the universe, Planck's constant. But why? Why does energy come in packets? Is it just a rule? No. It's because of waves, and specifically standing waves. Let's look at the electron again. Because everything you were taught in high school chemistry is a lie. Here is the lie. Open any high school chemistry book. Look at the atom. What do you see? A nucleus in the middle. Little balls called electrons orbiting around it like planets, like a solar system. This image is burned into your brain. The Bohr model. It's completely wrong, and not just a little wrong. It is mathematically impossible. If an electron were a charged ball moving in a circle, it would be constantly accelerating. Accelerating charges emit radiation. They lose energy. So if the solar system model were true, every electron in the universe would spiral into the nucleus in a fraction of a second. Poof! All matter would collapse. You would not exist. So why doesn't it happen? Because an electron is not a ball. It is a wave. But it's not a wave traveling through space. It's a standing wave. Imagine that guitar string again. Pluck it. It vibrates. Now imagine taking that string and wrapping it into a circle. If the length of the string matches the wavelength perfectly, the wave connects to itself. It reinforces itself. The crest meets the crest. The trough meets the trough. It sings a pure, steady note. But what if the string is just a little bit too long or too short? The crest meets a trough. They cancel out. Destructive interference. The wave dies instantly. This is the secret of the atom. The electron isn't orbiting, it is vibrating. It can only exist at distances from the nucleus where its wavelength fits perfectly around the circle. 1 wavelength, 2 wavelengths, 3 wavelengths. These are the shells you learned about. N equals 1, N equals 2, N equals 3. But you can't have 1.5 wavelengths. The wave would eat itself. So the electron simply cannot exist in the space between the shells. It's physically impossible for the wave to sustain itself there. This is why electrons jump. They teleport from one shell to another. They disappear from n equals 2 and reappear at n equals 1. It's not magic, it's just a change in the note. When you pluck a guitar string harder, it jumps to a higher harmonic. It doesn't travel through the frequencies in between. It just flips modes. The electron does the same thing. It absorbs a photon of light, energy, and pops up to a higher vibration mode, a higher shell. It emits a photon, light, and drops down to a lower mode. That light is the quantum leap. But why do these specific modes exist? Why these exact shapes? Why spheres and dumbbells and donuts? Because the electron isn't just a string. It's a 3D wave trapped in a 3D box. And when you solve the math for a wave in a 3D box, you get chemistry. You get the shapes of life itself. But first, we have to talk about the box itself. Because the box isn't made of wood. It's made of force. This is the part that will make you rethink your own existence. Look at a map of the world. Look at the borders of countries. They are arbitrary. They were drawn by politicians. If you zoom in on the ground, the dirt in France is the same as the dirt in Germany. But the universe doesn't have arbitrary borders. It has fundamental constraints. In physics, we call these boundary conditions. This is the box we've been talking about. For the guitar string, the boundary condition is the ends must be tied down. The displacement must be zero at the ends. This simple rule kills 99.999% of all possible waves. It only allows the discrete few that fit. Now look at an electron in a hydrogen atom. What is the boundary condition? It's not a physical wall. It's an electrical potential well. The nucleus is positive. The electron is negative. They attract. The electron is trapped in this potential well. It cannot escape unless you give it enough energy to break free. So the boundary condition is the wave function must go to zero at infinity. And inside the well, the wave must be continuous. It must be smooth. No sharp kinks. No sudden jumps in the value itself. These are mathematical rules, but they have physical consequences. When you solve the Schrödinger equation, the master equation of quantum mechanics, subject to these boundary conditions, something incredible happens. You get quantized energy levels. Without the boundary conditions, the Schrödinger equation allows for any energy. An electron could have 1.5 eVV or 1.500001 eVV. But the moment you add the constraint, it must be trapped. The math spits out integers. En equals minus 13.6 eVV per n squared, where n is an integer, 1, 2, 3. The energy levels are locked. They are discrete. This is why atoms are stable. If the electron could spiral into the nucleus like a classical particle, there would be no ground state, no minimum energy. It would just keep falling forever, releasing infinite energy. But because it is a wave, there is a fundamental limit, a lowest possible note, a ground state. The electron cannot fall any further because there is no lower note on the guitar string. The wave simply cannot fit in a smaller box. This is why matter doesn't collapse. This is why you are solid. You are made of waves that have hit the bottom of their range. But atoms aren't just one-dimensional strings. They are 3D spheres. And when you solve the wave equation for a sphere, things get weird. You don't just get notes, you get shapes. And these shapes are the reason why carbon bonds with oxygen, why water is bent, why DNA spirals. Chemistry is just geometry, and geometry is just standing waves. Let's visualize this, because once you see it, you can't unsee it. Imagine a drum, a round, taut skin stretched over a frame. When you hit a drum, it vibrates, but it doesn't just wobble randomly. It creates specific patterns. If you hit it right in the center, the whole surface goes up and down together, up, down, up, down. This is the fundamental mode, the simplest vibration. But if you hit it off-center, you can make one half go up while the other half goes down. There is a line across the middle where the drum doesn't move at all, a node. Hit it differently, and you get a circle in the middle that stays still while the center goes up and the edge goes down, another node. These are 2D standing waves on a surface. Now, take that idea and blow it up into 3D. Imagine a spherical drum, not a skin, but a ball of jelly or a cloud. When you vibrate this 3D sphere, you get 3D standing waves. Instead of lines where nothing moves, you get surfaces, nodal planes. If the whole sphere pulses in and out like a beating heart, that's the s orbital, a sphere. If the top half bulges out while the bottom half sucks in, that's the p orbital. It looks like a dumbbell or two balloons tied together. If you have 4 lobes bulging out in different directions, that's the d orbital, a clover leaf. These are the shapes you memorized in chemistry class, but nobody told you why they look like that. They look like that because they are the 3D equivalents of the waves on a guitar string. They are the only shapes that fit. The electron isn't a tiny ball zooming around inside these shapes. The electron is the shape. The orbital is the electron. It is the standing wave pattern of the probability cloud. The reason carbon can bond to 4 other atoms? Because its electrons form a tetrahedron shape. The reason water is bent at 104.5 degrees? Because the oxygen atom's p orbitals are at 90 degrees, but they repel each other slightly. Chemistry is just geometry, and geometry is just the result of confinement. The shapes of life, the double helix of DNA, the proteins in your muscles, the enzymes digesting your lunch, are all dictated by these standing wave patterns. You are a symphony of 3D drums. This is the punchline. This is where it all comes together. We started with a question. Why is the universe made of integers? Why can you count energy levels? N equals 1, N equals 2, N equals 3. Why do atoms have an integer number of protons? 1, 6, 8, 92. Why is there no element 6.5 or 92.7? Because nature isn't doing math. Nature is doing physics. Nature doesn't know what an integer is. Nature doesn't care about the number 3. Nature cares about constraints. When you confine a wave, you force it to become discrete. You force it to adopt the pattern. A pattern has distinct parts. You can count the parts. 1 hump, 2 humps, 3 humps. The integers emerge from the geometry. Look at a skipping rope. You can have 1 big loop, or 2 loops, or 3. You can't have 2.3 loops. It's physically impossible. The rope would tangle. The integers represent the number of nodes in the standing wave. This is a secret of quantum mechanics. It's not weird magic. It's just wave mechanics in a box. When you solve the Schrödinger equation for a hydrogen atom, the integers n, l, and m pop out automatically. They appear in the solution as the only values that make the equation solvable. They are the quantum numbers. But they are just labels for the shapes of the standing waves. N, L, M. Every atom in the universe is defined by these 3 integers. You are made of integers because you are made of confined waves, and confined waves can only exist in integer modes. So the pixelation of reality isn't a glitch, it's a feature. It's the only way a wave-based universe can exist without destroying itself. It's beautiful. But there's one last question. If reality is grainy, why does it look smooth to you? Why don't you see the pixels? Look at your hand. Move it through the air. It feels solid. It feels continuous. It doesn't feel like a flickering cloud of probabilities. Why? If the universe is pixelated, why don't we see the pixels? This is called the correspondence principle. And it basically says this. When things get big, quantum mechanics starts to look like classical mechanics. Think about a staircase. If the steps are huge, like 10 feet high, you notice every single jump. You climb 1 step, then another. It feels discrete. But if the steps are tiny, like 1 millimeter high, you don't notice the individual steps at all. It feels like a smooth ramp. Quantum mechanics deals with tiny, tiny steps. When you throw a baseball, its wavelength is incredibly small. So small it is effectively 0. The steps in its energy levels are so close together that they blur into a continuous line. The difference between n equals 1 million and n equals 1,000,001 is undetectable. So for big objects like baseballs, planets, and people, the quantum effects wash out. We live in the classical limit. But make no mistake, the steps are still there. If you look closely enough at anything, even a smooth ramp, you will find the atoms. You will find the quantization. The smooth world is an illusion created by the sheer number of tiny steps. We are giant creatures living in a world of averaged out quantum effects. But the most important thing to remember is this: the smoothness is the lie. The steps are the truth. The universe isn't a ramp, it's a staircase made of energy levels, and every single step exists because a wave was trapped in a box, because a boundary condition forced reality to make a choice, and that choice created the integers, and the integers created the atoms, and the atoms created you. So why does quantum mechanics exist? It exists because waves exist. And when you confine a wave, you get integers, you get lumps, you get quanta. It's not magic, it's music. The universe is a giant instrument. The atoms are the strings. The energy is the sound. And we are the song. Think about this. Every single atom in your body is vibrating right now. It is singing a specific note, a specific frequency. A carbon atom hums a different tune than an oxygen atom. And when they bond together, when they form molecules, they harmonize. They create chords. Water is a chord. DNA is a symphony. And you? You are an orchestra. Billions of tiny vibrating strings, all playing together in perfect harmony. The weirdness of quantum mechanics, the jumps, the uncertainty, the wave-particle duality, it's just the sheet music. It's the rules of the instrument. Without the rules, without the boundary conditions, the music would just be noise, chaos. But because the universe forces waves to fit into boxes, because it demands order, we get structure, we get chemistry, we get life. So the next time you look at a solid object, remember, it's not solid. It's just a standing wave that has found its note. And the next time you feel small, remember that you are made of the same music as the stars. The universe isn't made of particles. It's made of songs. And now you know the tune. Thanks for watching. If you want to hear more of the universe's music, hit subscribe, and I'll see you in the next one.